definite integral from 0 to 1 of 40 times x to the 7th. So we need to find the antiderivative of the small f of x here. Remember, we're pattern matching this to the definite integral from a to b of small f of x dx. Small f of x is 40x to the 7th. Our first step is to find an antiderivative of the small f of x, which is 40x to the 7th. So let's think about what would we need to take the derivative of to give us 40x to the 7th. Now, when I take a derivative, the number that's in front just stays in front. So really, I'm going to work on this power. If I think about the derivative of, it would actually be 1 over 8x to the 8th. But I've only accounted for this x to the 7th. I haven't accounted for the 40. But that's okay, because multiplication works the way you might hope when it comes to constant. So we've established that the antiderivative x to the 7th is 1 over 8x to the 8th. And to deal with this 40, we can just put it in front of both of these. So we end up 40 times 1/8 is 5. We end up that the antiderivative of 40x to the 7th is 5 times x to the 8th. And we need that step here. Our big f of x, and we always use big F for antiderivatives, 5x to the 8th. That's the hard part. From here, we're going to take our a and our b values, which are called the limits of integration, and we're going to do f of b minus, and this is a big F of b minus big F of a. So for this problem, that would be 5 times 1 to the 8th minus 5 times 0 to the 8th, which simplifies to be just 5. Antiderivatives are usually covered at the very end of Calculus 1 and perhaps reviewed at the very beginning of Calculus 2. But there's a problem. In Calculus 1, we're usually rushing to get through the end, and in Calculus 2, we're usually eager to get onto new things. So a lot of times antiderivative rules do not get covered in as great a depth as derivative rules do. So I also want to give you a strategy for how to practice these things more. My suggestions in building these skills would be to start small, really simple problems and build up, and to use the tools that we've covered. You know, we're not living in the 1970s anymore when you had one book and maybe you had one problem on definite integrals. You go to the back and you checked that one problem. We live in a world now where it's easy to find these things. You know, if I search definite integral problems, I get a lot of good resources in the first 5 hits. And the biggest thing you need to do here is to emphasize practice. So let's think about where we might start practicing. Like, what's the simplest kind of function I could think about? It's either going to be a linear function or a constant function. So what if I just take some arbitrary numbers and I can just say, I want to practice taking the definite integral from 0 to 4 of 2x dx. And I work through my process and I get my answer. Then you can check your answer in so many different ways. So one way you could check your answer is with Wolfram alpha. But type in integral from 0 to 4 of 2x dx. They also have this awesome new feature now where you can do math input, which means you would just be typing into the boxes, and that's new for me. I'm not used to it, but it's a pretty cool tool. And I click output, and it's going to give me the answer. And I can check my answer that I got when I did it against this. Symbolab will do a similar thing. You can do 0 to 4 2x dx and click go, and it will tell you the answer, and it'll even show you the steps here. And then if you feel like you're stuck on that, it's okay to request an intervention. And then if you feel like you're stuck on that, it's totally okay to request an intervention. You can email me, you can come to office hours, you can go to the Math Tutoring Center, you can talk to other people, you can go on Khan Academy, but start with that. Then once you've done a couple of those and feel like you mastered them, maybe you go on to the next type of problem. Maybe you start doing, a quadratic polynomial. The point is that you no longer have to rely on other people to make your practice problems. Hopefully we have a conceptual framework where you're able to start and think, I need to start with something very low level. Now, you will find worksheets, you will find notes where people have done this for you. And I totally understand the desire to do that. But when I've gotten feedback from students after the class, 2 or 3 years later, sometimes they'll be working at Walmart or Food Lion, and I come through their line and, they tell me about their experiences and how this calculus class prepared them. What they say is that the biggest thing they learned from the class was how to practice math, that they learned how to make up their own problems, think about it, and not be reliant. And in fact, one person even told me that they call it doing a pendulum. When they make up a new problem, they say, all right, let's do a pendulum. But this is something that if you think about, like you play basketball or do a sport, you don't always have to have a coach there there to guide you and correct you. Coaching is really important and teaching is really important. But when you practice on your own, you can do it in a free way, as long as you have the tools to assess whether or not you got the problem correct, whether or not the ball went in the basket. That's one of the things I hope you get out of this course. Not just that you've learned some rules, that you've also developed this ability to think about these problems and to explore them independently.